Hello everyone, welcome back to Mathematical Mindsets. Right here we have this ninth algebra math Olympiad problem, and the question says m multiply m minus m multiply m is equal to 100. So we are to solve for m. So right here we want to simply solve for m. So the first thing guys you want to do is to simply simplify this equation. So we have m multiply m multiply m. This is m raised to the power of 3 minus m multiply m is m squared, and this is equal to 100. So the next thing you guys want to note is that we can easily rewrite 100 to be 125 minus what 25. So from here we have m raised to the power of 3 minus m squared is equals to 125 minus 25. Alright, so the next thing we want to do is to simply rearrange this and set the equation to 0. So doing this right here, we have m raised to the power of 3 minus m squared minus into 125 minus 25, and this is equal to 0. So we have m raised to the power of 3 minus m squared minus 125 plus 25, and this is equals to 0. But we can easily express 125 in terms of 5 as 5 raised to the power of 3, and we can express 25 in terms of 5 as 5 raised to the power of 2. So this becomes s raised to the power of 3 minus m raised to the power of 2 minus 5 raised to the power of 3 plus 5 raised to the power of 2, and this is equal to 0. So rearranging this, we have m raised to the power of 3 minus 5 raised to the power of 3 minus have m raised to the power of 2 minus 5 raised to the power of 2, and this is equal to 0. So right here we want to simply apply the difference of cubic formula, and the difference of cubic formula is we have a raised to the power of 3 minus b raised to the power of 3. This is equal to a minus b into a square plus ab plus b square. So applying the difference of square formula, that says if we have a raised to the power of 2 minus b raised to the power of 2, this is equal to a plus b multiply a minus b, and from here we have that a is equals to m and b is equals to 5. So right here up to this point, we're going to have this to be, for m raised to the power of 3 minus 5 raised to the power of 3, we want to simply apply this formula. So this becomes m minus 5 multiply m square plus m multiply 5 plus 5 square minus, now for m square minus 5 raised to the power of 2, we are going to have this to be m plus 5 multiply m minus 5, and this is equal to 0. So we have this to be m minus 5 multiply m squared plus m multiply 5 is 5m plus 5 square is 25 minus m plus 5 multiply m minus 5, and this is equal to 0. So we want to simply factor out the common term, and the common term we have right here is m minus 5. So if we factor out m minus 5, we are going to have m squared plus 5m plus 25. Then if we factor out this, we have this to be m plus 5, and this is equal to 0. So we have m minus 5 into m squared plus 5m plus 25. So open up this bracket, we have minus m minus 5, and this is equal to 0. So from here, we have this to be m minus 5 multiply m squared plus 5m minus m is going to give us plus 4m, and 25 minus 5 is going to give us 20, and this is equals to 0. From this property that says if we have a b equals to 0, this implies that a is equals to 0 and b is equals to 0. So from here we have m minus 5 is equals to 0, and we have m squared plus 4m plus 20, and this is equals to 0. So m is equals to 0 plus 5, and m is equals to 5. So m1 is equals to 5. So for this, we want to solve using the quadratic formula. Now applying the quadratic formula that says m is equals to minus b plus minus the square root of b squared minus 4ac divide 2a, where a is equals to 1, b is equals to 4, and c is equals to 20. So from here we have that m is equals to minus 4 plus minus the square root of b square, which is 4 square minus 4 multiply a, which is 1, multiply c, which is 20, divide 2 multiply 1. So m is equals to minus 4 plus minus the square root of 4 square is 16 minus 4 multiply 1 multiply 20 is going to give us 80. Divide 2 multiply 1 is 2. M is equals to minus 4 plus minus the square root of 16 minus 8 is going to give us minus 64 over 2. So from here we have that M is equal to minus 4 plus minus. Now we can express negative 64 to be 64 multiply negative 1 over 2. M is equals to minus 4 plus minus the root of 64 multiply the root of negative 1 over 2. But the root of negative 1 is equal to I, so M is equals to minus 4 plus minus the root of 64 is 8 and the root of negative 1 is I over 2. So M is equal to, now we want to simply factor out a common term in the numerator, and the common term here is 2. So if we factor out 2, we have, so right here, in order for us to be able to get rid of the denominator, we want to simply factor out 2 from the numerator. So this becomes M is equals to 2 into minus 2 plus minus 4I over 2. Alright, so from here we have that M is equal to, this is going to cancel out this, so we have minus 2 plus minus 4I, and this becomes the other value for M. So right here we can say hence the values for M are given as the values of M. We have that M1 is equal to, so let's simply scroll back right here and see the value of M1, which is equals to 5. So we have that M1 is equal to 5. M2 is equals to, so right here we want to take a look at M2. We have M2 to be minus 2 plus 4I, and M3 is equals to minus 2 minus 4I. And these are complex roots right here, and we have M1 equals to 5 is the real root. Okay, so right here we want to simply verify by making use of the real roots, and we have this right here. So we're going to say to verify, we have that M multiply M minus M multiply M is equals to 100, and we have the real root, which is M1 is equals to 5. So this can be expressed as M raised to the power of 3 minus M raised to the power of 2. This is equal to 100. Now M1 is equals to 5, so we have 5 raised to the power of 3 minus 5 raised to the power of 2, and this is equal to 100. 5 raised to the power of 3 is 125 minus 5 squared is 25, and this is equal to 100. So 125 minus 25 is going to give us 100, which is equals to 100. So therefore, M1, which is equals to 5, which is the real root, is a valid solution. Okay, so we have been able to solve this question right here. Alright guys, so this is how you can solve this type of question, and if this video is really helpful, please do not forget to subscribe to Mathematical Mindset and give this video a thumbs up.